Good day, I am Mikael Alexis El Parantar and I am here to discuss my understanding on measuring distance on a Mercator chart and why its longitude is not used when measuring distances on the chart. So, introduction. What is chart work? A chart work is practice done by navigators that involve plotting courses and other navigational process on a chart. Chart work is crucial to passage planning and safe coastal cruising. Accurate chart work is the basis or good navigation. Before going to sea, a course is plotted on a chart, noting bearings, distances, and expected times for each leg of the trip. While at sea, position is fixed at regular intervals and the course adjusted when necessary. Instruments for plotting. An increasing number of mariners today rely on automated tools such as GPS for navigation and getting from one point to another. Indeed, a good marine GPS will not only replicate a chart's details, but it can aid in determining course, distance, elapsed time, and position. Materials needed when plotting: navigational chart, compass dividers, pencil and eraser, parallel ruler, protractor triangle, chart plotter, and etc. The parallel ruler can also be used as a straight edge when connecting 2 points on a chart. Some parallel rulers, such as the one in the figure, have additional protractor markings around the edges, allowing the course heading to be determined by moving the rule to any line of meridian on the chart, rather than only the compass rules. A parallel plotter has a roller that allows the device to be moved across a chart without changing its orientation. Most roll plotters have protractor markings, allowing the heading to be determined without having to move to a compass rose. The plotter can also be used as a regular straight edge. Another common tool is the protractor triangle. In addition to being a straight edge, it can also help find the heading when used in conjunction with a parallel ruler or roll plotter. The second tool most commonly associated with plotting and navigation is a pair of dividers. Dividers are used to mark the distance between 2 points on the chart, or to mark points on the chart at which to place a ruler, parallel ruler, or roll plotter. Note that the dividers have 2 points at the end. Replacing one point with a pencil or lead marker turns this into a compass. Measuring distance. Distances can be determined using dividers or a ruler, although the former is more commonly employed because it can be used with more precision. The most common way to determine a distance is to set the dividers to the length of the line connecting 2 points. The dividers are then placed against a scale on a chart to find the actual geographic distance. In most cases, plotting problems require determining distances in nautical miles. Remember that a minute of latitude is equal to 1 nautical mile. Thus, the distance of a line on a chart can be determined by holding the dividers up to the latitude scale on the side of the chart. As an example, suppose we want to measure the distance between 2 points on a chart. In this example, between two buoys. First, set the dividers to the 2 points over which to measure the distance. Next, place the dividers against the latitude scale on the chart to find the distance, which is approximately 3.8 nautical miles. If the line connecting the 2 points is larger than the span of the dividers, set the dividers to a span representing a no distance, and then count the number of increments of your compass span in order to cover the length of the line. Finding latitude and longitude. Determining the latitude and longitude from a point of the chart is a fundamental skill and is relatively straightforward. The easiest way to determine latitude is to orient the parallel ruler on a horizontal line on the chart and then walk the parallel ruler until it meets the point of interest and lines up with the chart's horizontal scale. The latitude can be read from the scale. Figure 2.10 shows an example of this process. In order to find the position of green buoy number 3 on the chart, start by positioning the parallel ruler through the horizontal line at 54 degrees 35 minutes north, and then walk the ruler to run through the buoy's position in the horizontal scale. Next, position the parallel ruler through the vertical line at 83 degrees 15 minutes and walk the ruler to run through the buoy and the vertical scale. The lines show the position of the buoy to be 54 degrees 35.5 minutes north and 83 degrees 12.8 minutes west. Remember that charts are always oriented with the true north towards the top. When looking at this chart, notice that the minutes on the vertical scale increase going from bottom to top. This means that this chart is in the north latitudes. Similarly, the minutes along the horizontal scale are increasing from right to left, meaning that the chart is in the western longitudes. Plotting a position. Plotting a position from latitude and longitude is the opposite of determining those coordinates. In this case, you are given the latitude and longitude and need to find out where you are on the chart. Suppose you need to find position 54 degrees 34.5 minutes north, 83 degrees 21.7 minutes north on the chart. Use your parallel ruler to mark a line at the proper line of latitude and another at the proper line of the longitude. The intersection of the two lines is your position. Finding a true bearing and compass course. When laying out a course on the chart, it is important to remember that all headings relative to true north. There are times when you need to account for variation and deviation, such as when you obtain a magnetic heading from a compass or need to determine what compass heading to steer on your vessel. But plotting routes on a chart are always true. This section describes how to find the compass course knowing an initial point and an intended destination. Another term for this is the intended course. If you know the 2 points and want to find the course between them, this is sometimes referred to as the course made good, which is the actual course you took between the 2 points after accounting for compass variance and deviation, wind, tide, current, and other factors. This section describes how to find the compass course knowing an initial point and an intended destination. Another term for this is the intended course. If you know the 2 points and want to find the course between them, this is sometimes referred to as the course made good, which is the actual course you took between the 2 points after accounting for compass variance and deviation, wind, tide, current, and other factors. As an example, suppose you need to plot your course from latitude 54 degrees 35.5 minutes north, longitude 83 degrees 20.5 minutes west to red buoy number 4. Number 1. Find the 2 points and draw a line between them. This is called track line. Line up your parallel ruler and walk it to the compass rose. Note that your line will intersect the compass rose in 2 places. To select the proper heading, you need to recall that you started a couple of miles east of the face and headed towards the buoy. Therefore, you know that you will be going roughly southwest, which means that you want to be in the southwest quadrant of the compass rose. Alternatively, if you were at the center of the compass rose, you would be moving down and to the left. In either case, you should see that the line intersects the outer compass ring at 200 degrees true. It's worth remembering that only the vertical latitude scale on a Mercator chart can be used to measure distance, not the horizontal longitude scale. This is because each minute of latitude is equal 1 nautical mile, while the distance between minutes of longitude decreases between the equator and the poles.